So, good afternoon, guys. So, for now, okay, let us have some preview of the Morse method, which is tackled last week, okay? So, Morse method, okay? So, Morse method, meron tayo dyang neutral medium or neutral media. Okay? So, silver nitrate, okay, in the burette, which is the titrant, okay? Potassium chromate or sodium chromate as your indicator. Okay? So, once the equivalent point or once the end point has been reached, okay? So, excess silver ions cause the formation of a reddish-brown, okay, silver chromate precipitate. Okay, so again, so once the equivalent or the endpoint has been reached, so excess silver ions cause the formation of a reddish-brown silver chromate precipitate. Okay? So now, so kung makikita nyo dyan, titration ready to start. Okay, so titration in progress. So equivalence point. Okay, color changes when silver is in excess. So kung reddish precipitate, ayan na. So kung makikita nyo, dito sa burette, okay, so sa silver, then yung mga silver na yan, okay, yung excess silver, nandito na siya sa mismong Erlenmeyer flask, it will made the solution more reddish. Okay? So, that's the sense of your Morse method. So, next po is the Volhard method. So, kung kanina, kay Morse method, naka-neutral tayo, medium. Now, kay Volhard method naman is naka-acidic medium tayo. Okay? So, this method, okay, is determined chloride ion by titrating with silver, okay, using back titration. Okay, so pag sinabing back titration, okay, it is a titration, of course, where the concentration of an analyte is determined by reacting it with a known amount of excess reagent. Okay? So, known excess silver nitrate is added to the solution, so quantity of excess silver ions determined using back titration with potassium thiocyanate. So, ammonium iron 3 sulfate as indicator. Okay, so ayun yung indicator na gamit natin. So, once all the silver ions has been precipitate with thiocyanate, excess thiocyanate forms red ferrous thiocyanate complex ion. So, ang process kasi dyan, guys, is first, okay, so, chloride ion is precipitated by excess standard silver nitrate. Okay, so, yung silver nitrate, ayun na yung known quantity nyo. Okay, so, ang process dyan, so, silver, okay, yung excess silver plus the chloride, so, parehas silang aqueous, so, magkakaroon tayo ng solid precipitate na silver chloride. Excuse me. The precipitate is isolated and the excess silver is titrated with standard thiocyanate, okay, solution in the presence of ferric ion or Fe3, okay? Now, after all the silver has been consumed, the thiocyanate reacts with ferric to form a red complex. So, ito na yon, yung ferric thiocyanate. So, red complex yung mabubuo kay Volhard method. So, problems encountered during the experiment of Volhard method. So, the end point, okay, slowly fades because silver chloride is more soluble than silver thiocyanate. So, the silver chloride slowly dissolves and is replaced by silver thiocyanate. So, nagkakaroon ng interaction, nagkakapalit sila ng ang sense, okay? Nagkakapalit sila ng purpose within the experimentation. So, ano yung pwedeng gawin natin? Okay? So, first, okay, so filter off the solid silver chloride. Okay? So, filter off the solid silver chloride and only the silver left in the filtrate. Okay? Yung nasa yung pinaka-solution. Okay? Kasi yung filtrant nyo na, yun yung yun yung nasa filter paper. Okay? Kasi andun na yung solid eh. Ibig sabihin, ayun dun yung um, silver chloride. So, meron kayong makikita, okay, doon sa pinaka-solution, okay, ayun na yung silver left in the filtrate. Okay, so, ngayon, ang gagawin nyo, add a few ml of nitrobenzene with the silver chloride precipitate and shake. Okay, now, yun yung gagawin natin sa, ayun yung solution natin for the problem number 1. Now, the problem number 2, okay, so possibility of ferric ion to hydrolyze to form iron hydroxide or iron 3 hydroxide under alkaline conditions. So, what we will be do, okay, in that problem is perform titration under slightly acidic medium. Okay, again, the solution on that is perform titration under slightly acidic medium. Okay, so now, in Volhard method, okay, so before the titration, okay, so addition of thiocyanate ion. Next is formation of silver thiocyanate precipitate. And faint yellow color must be observed before the end point. Now, during the end point, all silver completely consumed. Excess thiocyanate reacts with ferric ions. Ferric ammonium sulfate, okay, indicator, okay, so slightly orange or red color na to. Okay, so after the end point, nakatulad pa rin dati na meron tayong silver excess, okay, so further formation of ferric thiocyanate. Stronger, dark, red color na yung mapoproduce nyo. So meaning, ito yung inyong endpoint. Okay, so stronger, dark red color. Okay, again, before endpoint, meron tayong first, addition of thiocyanate ion. Second, formation of silver thiocyanate precipitate. And the third, faint color, a faint yellow color must be observed before the endpoint. Now, during the endpoint, okay, so all silver completely consumed. Second is excess thiocyanate reacts with ferric ions. Next is ferric ammonium sulfate, which is our indicator, must be added. Okay, so slightly orange or red color. Now, after the endpoint, na alam natin na meron tong excess silver, so further formation of ferric thiocyanate, so magpo-form siya ng stronger dark red color. Next po, so Fajan's method. So in Fajan's method, okay, so neutral medium. So same, silver nitrate din yung nasa burette. So anionic colored dye. Okay, so meron tayo ditong dichlorofluorocane. Okay, dichlorofluorocane as your indicator. So, anions dye, okay, so is replaced by chloride ions that stick or adsorb, okay, to the surface of the silver chloride precipitate. Okay, once the equivalence point has been reached, okay, excess silver ions are adsorbed to the surface of the precipitate, attracting the anionic dye. Okay, so nagkakaroon ng attraction na adsorb. Okay, color changes from greenish yellow to pink. Again, color changes from greenish yellow to pink. So, ang indicator na gagamitin natin dito, yung anionic colored dye, which is your dichlorofluorocane. Okay? So, adsorption yung nangyayari kay Fajan's method. Tulad ng nasabi natin before. So, before the endpoint or equivalence point, so first, addition of silver to chloride. Second, formation of colloidal silver chloride. Okay? So, at the endpoint or during the equivalence point, all silver has been consumed. After, okay, the equivalence point, same pa din, may excess silver. Okay? So, anion dyes, okay, your dichlorofluorocane, okay, and its derivatives, okay? So, adsorption indicators to mga to, adsorb on silver chloride surface. So, excess silver reacts with fluorine causes to pink precipitate. Okay? So, ganyan po yung magiging result. Okay, excess silver reacts with fluorine causes to pink precipitate. So, please take note lang guys na solution, should be slightly alkaline. Okay? So that indicator keep in an ion form. So, only slightly alkaline to avoid silver ions which will be convert into silver hydroxide. So, kailangan natin ma-avoid yon. Okay, kaya dapat slightly alkaline lamang po. So, strong acids of other dichlorofluorosane derivatives can be used in acidic pH. For example, ng derivatives ng dichlorofluorosane is your AUCin Y. Okay, so that's the example po. So, limitations na tayo. So, tapos na tayo kay Moore, kay Fajans, kay Volhard. So, limitations, okay? A few number of ions such as halide ions. So, ano-ano itong mga to? Your chlorine, bromine, and iodine. Okay? Can be titrated by, okay? Can be titrated, okay, by precipitation method. Okay? Co-precipitation may be occurred. Next po is, it is very difficult, okay, to detect the endpoint. Bakit natin sinasabing co-precipitation may be occurred? So, minsan kasi guys, other compound or other component, okay, they can produce, okay, other precipitate. That's why, nagkakos yan ng hindrance or nagkakaroon tayo ng problem when it comes to identifying the real equivalence point of the experiment. Okay, so ganun po yung pwedeng mangyari. So, wait lang po. Okay, next po is application of precipitation titration. Okay, so the determination of chlorine contained in natural water. So, dito po papasok si Moore at si Volhard method. Determination of silver contained in silver ion. Ito naman kay Volhard method. So, number 3, determination of halogen contained in organic compounds such as food, organochlorine, pesticides, okay? So, ang ginagamit pa rin naman natin dito is si Volhard method, okay? So, the precipitation titration, okay, is observed when the salt is occurred and indicators is used to see the pH range. So, most used for neutralization titration po ito. Yung number 4 na application of precipitation titration. So, precipitation titration is used for such reaction when the titration is recognized by changing the colors, okay, during the reaction. A salt is precipitated as the titration is completed. So, ganun po yung application. So, meron pa tayong last two. Okay? So, precipitation titration, okay, is an amperometric titration. Okay? So, di ba, may sensors tayo, yung potentiometric, and your amperometric. So, si precipitation titration is amperometric titration. Aside from being a sole electrode, ito rin ay in which the whole potential of a suitable indicator electrode is measured during the titration. Okay, kung makikita nyo yung definition natin, okay, before kay titration ay kay amperometric, okay, kung matatandaan nyo pa siya, okay, so, ganun po, okay, sabi natin kay amperometric before, okay, so, controlled instrumentally, and the current occurring as consequence of the redox reaction at the electrode surface is recorded as the analytical signal. So, ayan po yun. So, nagkakaroon tayo ng measurement during the titration. That's why it is amperometric. Okay? So, next po, it is used for the determination of chloride by Moore method using silver nitrate. So, dyan po muna tayo. Okay? So, next meeting po is for the last topic for the precipitation titration po based on the contents po. So, thank you so much po. Have a good day.